March 30th, 1941. Inside the offices of the George A. Fuller Company in New York City, two men received an impossible assignment from the United States Navy. The war clouds gathering over Europe and the Pacific had finally forced America's hand, and the military needed a solution to a problem that threatened to cripple any overseas deployment before it even began. How to house millions of men and tons of equipment across a global battlefield that stretched from Iceland to the Pacific Islands, from North Africa to the Aleutians. The Navy's deadline was brutally simple: 2 months to design, prototype, and begin mass production of a revolutionary portable building that could be erected by untrained personnel in remote locations under enemy fire. Peter Dejongh, an engineer, and Otto Brandenberger, an architect, stood in their office that spring afternoon, staring at a handful of drawings. The Navy had provided blueprints of a British structure called the Nissen hut, a relic from the previous World War. The challenge before them was staggering in its scope and urgency. They needed to create not just a building, but an entire manufacturing system, and they needed to do it faster than anyone had ever designed and produced a major military structure in history. The Navy was asking for the impossible, but the Fuller Company's reputation had been built on achieving exactly that. What neither man knew that afternoon was that they were about to create one of the most iconic structures of the 20th century. A building so simple, so versatile, and so effective that it would house more American servicemen than any structure in history, and its curved steel silhouette would become synonymous with military life for an entire generation. The desperate problem facing the United States military in early 1941 was one of logistics on an unprecedented scale. As Nazi Germany tightened its grip on Europe and Imperial Japan expanded across Asia, America's military planners confronted a sobering reality. Even if they could recruit, train, and transport millions of soldiers across oceans, those men would need shelter once they arrived. Traditional construction methods were impossibly slow, required skilled craftsmen who were needed elsewhere, and demanded materials that would consume precious shipping space. A standard military barracks required weeks to build, needed experienced carpenters and masons, and couldn't be moved once constructed. The British, already fighting for their survival, had shown the consequences of inadequate infrastructure. Their forces were scattered across territories from North Africa to Southeast Asia, and their logistical systems were stretched to the breaking point. The statistics were staggering. America would eventually deploy more than 10 million troops during World War II, and each of those men needed a place to sleep, work, and store equipment. A 25-man barracks tent with wooden flooring required significant shipping space and offered minimal protection from the elements or enemy bombardment. Conventional buildings were out of the question. There simply wasn't time or manpower to construct thousands of permanent structures across dozens of countries and hundreds of islands. The Navy's Bureau of Yards and Docks, under the command of Admiral Ben Moreell, had been tasked with solving this seemingly impossible equation. Create shelter that was lightweight enough to ship efficiently, simple enough for non-specialists to assemble, sturdy enough to withstand everything from Arctic gales to tropical typhoons, and cheap enough to produce by the tens of thousands. Admiral Moreell, a civil engineer by training, understood that this wasn't merely a construction challenge. It was a question of whether America could project power globally at all. Without adequate infrastructure, advanced bases would fail, troops would be exposed to the elements and enemy fire, and equipment would deteriorate in harsh conditions. The British had developed a solution during the First World War, but their Nissen hut, while functional, was notoriously uncomfortable. Soldiers described them as cold, drafty metal tubes in temperate climates and suffocating ovens in the tropics. Most Nissen huts had concrete or dirt floors, no insulation, and minimal amenities. They were, in essence, corrugated steel shells stretched over metal frames, better than nothing but barely. Moreell knew that American forces would need something better, something that balanced the urgency of wartime production with the recognition that soldiers living in miserable conditions would have poor morale and reduced effectiveness. The unlikely solution arrived in the form of a British precedent and American innovation. When the Navy approached the George A. Fuller Company in late March 1941, they brought with them blueprints of the Nissen hut. Peter Dejongh and Otto Brandenberger studied these drawings with the critical eyes of men who understood both the promise and the limitations of the design. The Nissen hut had been conceived during World War I by Major Peter Norman Nissen of the 29th Company Royal Engineers, a Canadian-born British officer who was a mining engineer and inventor by training. Between April 16 and 18, 1916, Nissen had constructed 3 prototype semi-cylindrical huts at a British military facility. His design drew inspiration from an unlikely source, the curved roof of a drill shed at Queen's University in Kingston, Ontario, which had collapsed in 1896. Nissen's innovation had been revolutionary for its time. Working with fellow officers including Lieutenant Colonels Shelley, Sewell, and MacDonald, and General Clive Gerard Liddell, Nissen refined his design through intensive review and field testing. After the 3rd prototype was completed, the design was formalized and put into production in August 1916. At least 100,000 Nissen huts were produced during the First World War, and they served across every theater of that conflict. Nissen had patented his invention in the United Kingdom in 1916, with subsequent patents in the United States, Canada, South Africa, and Australia. He received royalties from the British government, not for huts made during the war itself, but only for their sale afterward, earning some £13,000 and being awarded the Distinguished Service Order. But Dejongh and Brandenberger recognized immediately that the Nissen design, while groundbreaking for 1916, was inadequate for America's needs in 1941. The basic shape was sound. The semi-cylindrical design provided excellent structural strength and shed rain and snow effectively. But the execution left much to be desired. Nissen huts required an interior frame with metal sheeting bolted on top, a time-consuming assembly process that required more skilled labor than the Navy wanted to commit. They had no insulation, making them unbearable in extreme temperatures. They lacked proper flooring, proper ventilation systems, and standardized provisions for windows and doors. Most critically, they were difficult to modify or expand once erected. Otto Brandenberger brought a unique perspective to the challenge. He was the George A. Fuller Company's only staff architect, and his background included exposure to Bauhaus design principles, the modernist philosophy that emphasized functional form, geometric simplicity, and the elimination of unnecessary ornamentation. The Quonset hut would become, in many ways, the perfect expression of Bauhaus thinking applied to military necessity. A purely geometric form that could house many uses, utterly devoid of decoration, and designed to be mass-produced efficiently. Peter Dejongh, meanwhile, focused on the engineering challenges. How could they eliminate the complex interior framing? How could they make assembly simple enough for soldiers with no construction experience? How could they reduce weight without sacrificing strength? The battle of development began immediately, and it was a race against time that seemed designed to fail. The Navy's order on March 30th gave them until June 1st, just 2 months, to design the hut, build a manufacturing facility, tool up production lines, train workers, and begin delivering finished units. To put this timeline in perspective, conventional military construction projects of that era typically took months just for the design phase, followed by competitive bidding processes, contract negotiations, and then actual construction. Fuller was being asked to compress all of that into 8 weeks. The company's response was audacious. Within 30 days, they had constructed a sprawling manufacturing plant near Davisville, Rhode Island, in the heart of what would become the massive Quonset Point Naval Air Station complex. The plant was built while Dejongh and Brandenberger were still working out the design details, a parallel development process that violated every conventional rule of construction and manufacturing. The factory began producing Quonset huts while the design team was still making modifications and improvements, a testament to both the urgency of the situation and the confidence Fuller had in its team. The design evolution happened at breakneck speed. The first prototype measured 16 feet wide by 36 feet long, with an 8-foot radius. The frame consisted of T-shaped steel ribs, 2 inches by 2 inches by a 1/4 inch, spaced along the length of the structure. But even as the first units rolled off the production line, Dejongh and Brandenberger continued refining the design. They made so many changes and improvements to the basic Nissen hut concept that they essentially started from scratch, creating an entirely new structure that only superficially resembled its British predecessor. The innovations were both dramatic and subtle. The Fuller team replaced the Nissen hut's dirt or concrete floors with a 1-inch tongue-and-groove plywood floor supported on a raised metal framework, instantly making the interior more comfortable and warmer. They added wood fiber insulation between the outer corrugated steel shell and an inner lining of masonite or pressed wood, creating a barrier against both heat and cold that the Nissen hut completely lacked. They standardized provisions for doors, windows, and chimneys, allowing the huts to be customized for different climates and purposes. Most importantly, they designed a system where all components could be shipped in standardized crates and assembled with minimal tools and training. One of the most critical innovations came from a subcontractor. Anderson Sheet Metal Company of Providence, Rhode Island, was tasked with developing a method to curve the corrugated steel sheets to conform perfectly to the arched ribs of the structure. The original Nissen design used flat sheets that were formed and anchored with a complex system of cables and turnbuckles, a time-consuming process that required adjustment and skill. Anderson's engineers experimented with bending techniques until they discovered a methodology for curving sheet metal without deforming the corrugations, creating panels that fit precisely onto the frame. This breakthrough eliminated the need for the cable and turnbuckle system and dramatically reduced assembly time. The project nearly failed at multiple points. Material shortages were constant. Steel was desperately needed for ships, tanks, and aircraft, and securing allocation for Quonset production required persistent advocacy from Admiral Moreell's office. Shipping space was even more precious, and every design decision had to consider the volume the components would occupy when crated. The Fuller factory couldn't keep up with demand once production began. In June 1941, the first Quonset huts were shipped to Britain under the Lend-Lease program, arriving even as the Battle of the Atlantic raged and U-boats hunted supply convoys. The Navy quickly realized that a single manufacturer couldn't possibly produce the quantities needed, and they let out a second contract to Stran-Steel, a division of the Great Lakes Steel Corporation in Detroit, Michigan. Stran-Steel's entry into production brought another wave of innovations. Their engineers redesigned the arch ribs, creating them from two mirror-image U-shaped steel stampings welded back to back. The welds left a narrow gap between the stampings that had the shape of a stretched-out W when viewed from above. This seemingly minor change was actually brilliant. Instead of requiring nuts and bolts to attach the corrugated steel exterior and interior masonite panels, workers could simply drive nails through the materials and into the ribs, where the W-shaped gaps would grip the nails more tightly than wood. Stran-Steel came up with an efficient system that allowed simple nailing of the corrugated steel skins and interior masonite liner sheets to the arched frames, further reducing erection time and eliminating most of the nuts and bolts used in early models. The company's innovation meant that anyone who could hammer a nail could assemble a Quonset hut, exactly what the Navy needed. By the time the design stabilized, the Quonset hut existed in two primary sizes. The standard model, known as the 20, measured 20 feet wide by 48 feet long, with a 16-foot radius, providing 960 square feet of usable floor space. Optional 4-foot overhangs at each end provided weather protection for entrances. The larger model, the 40, nicknamed the Elephant Hut, stood 40 feet wide by 100 feet long, providing 4,000 square feet of interior space. This massive warehouse-scale structure could be used for storage, hospitals, maintenance facilities, or any application requiring large open floor space. The Navy also developed specialized versions for different climates. A northern design with solid wooden end plates for cold weather, a southern design with screens on both ends for moderate climates, and a tropical design with screened bulkheads, a raised roof for ventilation, and extra vent flaps along the lower sides. The standard 20-footer could be shipped knocked down in 12 large wooden crates weighing approximately 7,000 pounds total. Remarkably, this took up less shipping space than a 25-man barracks tent with wooden flooring, a crucial advantage when every cubic foot of cargo space on transport ships was precious. A team of 6 to 10 men, even those with no construction experience, could erect a Quonset 20 in a single day. The world record for assembling a Nissen hut, the British predecessor, had been 1 hour and 27 minutes, achieved by an experienced crew under ideal conditions. The Quonset hut couldn't quite match that speed, but it more than made up for it in comfort, versatility, and ease of modification. The enemy's fatal blind spot was rooted in doctrine, intelligence assumptions, and cultural arrogance. Both Nazi Germany and Imperial Japan had constructed detailed assessments of American industrial capacity and military potential during the 1930s, but their analysts fundamentally misunderstood the nature of American manufacturing innovation. German and Japanese military planners assumed that rapid global deployment would be impossible for the United States because of logistical limitations. Specifically, the inability to construct adequate infrastructure quickly enough to support large-scale operations in remote locations. Their own military systems relied heavily on captured or requisitioned existing facilities, with field operations supported by more traditional tent encampments and temporary structures that took considerable time to establish. Japanese intelligence, in particular, had carefully studied the American military during the 1920s and 30s and concluded that while American industrial capacity was formidable, the U.S. military lacked the organizational efficiency and rapid deployment capabilities of the Imperial Japanese Armed Forces. The Japanese had perfected a system of minimalist field operations, with troops trained to endure harsh conditions with minimal shelter. They believed this gave them a decisive advantage in the Pacific, where island warfare would require rapid movement and adaptation. The Germans, meanwhile, assumed that American forces, if they ever deployed to Europe in significant numbers, would be months behind their advance, struggling to establish supply lines and rear area facilities, while German forces consolidated their conquests. Neither Axis power anticipated the Quonset hut or structures like it. The speed with which American forces could establish fully functional bases in remote locations, complete with housing, medical facilities, repair shops, storage warehouses, and administrative offices, shocked both German and Japanese commanders when they encountered it in theater. The intelligence failure was not in underestimating American industrial capacity per se, but in failing to understand the American approach to problem-solving through innovation and mass production. The Quonset hut represented a fundamentally different philosophy. Rather than training troops to endure privation, American military doctrine sought to maintain combat effectiveness by providing adequate shelter and facilities even in the most forward positions. The reversal came swiftly and across multiple theaters simultaneously. In June 1941, the first Quonset huts arrived in Britain under Lend-Lease, months before the United States officially entered the war. British commanders were initially skeptical. They had lived with the limitations of Nissen huts for 25 years and assumed this would be merely an American variation on a familiar theme. What they discovered instead was a structure that was warmer, more comfortable, faster to erect, and more versatile than anything in their inventory. By the time Admiral Moreell formally established the Naval Construction Battalions, the famous Seabees, on March 5, 1942, Quonset huts were already proving their worth across the Atlantic and in Iceland. The Seabees became inseparable from the Quonset hut story. These construction battalions, formed from men recruited directly from the construction trades, became the primary erectors and users of Quonset huts in both the Pacific and Atlantic theaters. Admiral Moreell's vision for the Seabees was revolutionary. Breaking a long-standing Navy tradition, Secretary of the Navy Knox agreed on March 19, 1942, that Civil Engineer Corps officers rather than line officers would command these units. This decision and Moreell's foresight in creating the Seabees in the first place earned him the title Father of the Seabees, and made him the first, youngest, and only non-Naval Academy graduate and Civil Engineer Corps officer to be promoted to admiral. Between 1942 and 1945, the Seabees built 111 major airstrips, 441 piers, 2,558 ammunition magazines, 700 square blocks of warehouses, hospitals to serve 70,000 patients, tanks for storage of 100 million gallons of gasoline, and housing for 1.5 million men. It is safe to assume that the Quonset hut was the basic building for most of these operations. In the North, Central, South, and Southwest Pacific areas, these structures became the backbone of American military infrastructure. The Seabees suffered more than 200 combat deaths and earned more than 2,000 Purple Hearts while performing these construction miracles, often working under enemy fire. The battlefield shock for Axis forces came in multiple forms. In the Pacific theater, Japanese commanders who had expected American forces to struggle with establishing secure rear areas instead found fully functional bases springing up on captured islands within days of invasion. After the fall of Guam, American forces constructed what was called the Multiple May West, a 54,000 square foot warehouse created by joining Quonset huts together, capable of storing enormous quantities of supplies. The speed of this construction, and the comfort and functionality of the resulting facility, represented a logistical advantage that Japanese forces simply couldn't match. Their own supply lines were being strangled by submarine warfare and aerial bombardment, while American bases multiplied and expanded with seeming ease. In Europe, similar patterns emerged. Before the Normandy invasion in June 1944, Seabees constructed massive supply depots across southern England in preparation for the battle. The largest single base was built on a golf course in Exeter, Devon, beginning construction on October 11, 1943. This depot included 578,000 square feet of covered storage, most of it provided by 40 by 100-foot Quonset huts, personnel quarters for 1,000 men provided by standard-sized Quonset huts, office facilities, and 7 miles of roadway to serve the base. The speed of this construction, and the durability of the structures under the harsh Atlantic weather, impressed British military observers who had grown accustomed to more traditional construction timeframes. German intelligence reports from 1944 and early 1945 noted with alarm the rapidity of American base construction in liberated territories. Unlike German forces, which required extensive logistical preparation and established supply lines before major operations, American units seemed able to establish functional forward operating bases almost overnight. The psychological impact on German commanders, already reeling from the sheer scale of American material superiority, was significant. The Quonset hut became a symbol of American industrial might, not because it was technologically sophisticated, but because it demonstrated the American ability to solve complex logistical problems through innovative mass production. The expansion and multi-role impact of the Quonset hut exceeded even the Navy's initial expectations. Between 150,000 and 170,000 Quonset huts were manufactured during World War II, enough to house the combined populations of Portland and Seattle. The structures served in every conceivable role. Beyond barracks and storage, they became latrines, clerical offices, bakeries, isolation wards, medical and dental offices, mess halls, chapels, theaters, and bomb shelters. In Iceland in late 1941, a severe gale crumpled PBYs on the beach like paper hats and ripped the covering completely off many of the British Nissen huts, but left the Quonset huts practically undamaged, according to Fuller Company records. The before and after contrast was stark. Before the Quonset hut, forward base construction was measured in weeks or months. A conventional barracks building required skilled carpenters, masons, plumbers, and electricians, specialists who were desperately needed elsewhere. Traditional construction consumed enormous quantities of lumber, which had to be shipped at great expense, and the resulting structures were permanent, unable to be relocated if tactical situations changed. After the Quonset hut's deployment, base construction was measured in days. The Fuller factory initially produced 40 huts per day prior to Pearl Harbor. After December 7, 1941, production expanded to 150 units each day. When combined with Stran-Steel and other contractors' production, thousands of huts were being shipped to theaters worldwide every week. The tropical climate of the South Pacific posed particular challenges, leading to specialized designs. The standard corrugated steel Quonset could become unbearably hot under the intense sun, so engineers developed versions with raised roofs for ventilation and screened, rather than solid end walls. In some cases, wooden-framed huts covered with waterproof masonite board replaced steel construction to conserve metal resources while maintaining the basic Quonset design principles. The flexibility of the basic design allowed for these adaptations without requiring entirely new manufacturing systems. In the European theater and North Africa, Quonset huts in battle zones were often banked with 5 or more feet of earth to protect against bomb explosions. The semi-cylindrical design proved ideal for this purpose. The curved shape distributed blast forces more effectively than rectangular structures, and the steel construction held up remarkably well under bombardment when properly bermed. The Germans, who had invested heavily in concrete bunker construction, found that American forces could achieve similar protective results with earthen berms around Quonset huts at a fraction of the time and expense. The structures were also joined together in various configurations to create larger facilities. Several Quonsets could be connected end-to-end to create extended buildings, or placed side by side with connecting passages cut through the walls. This modularity allowed commanders to expand facilities as needed without requiring entirely new construction projects. The two basic sizes, the 20-footer and the 40-footer, could be mixed and matched to create complex installations. Field hospitals, for example, might use 40-footers for surgical theaters and recovery wards, with 20-footers serving as examination rooms, administrative offices, and storage. The The psychological aftermath of the Quonset hut's deployment manifested in both Allied morale and Axis demoralization. For American and Allied servicemen, the Quonset hut became a symbol of home, or at least of relative comfort in a world of chaos. While soldiers' accounts of life in Quonset huts were not universally positive, British troops stationed in the United Kingdom found them cold and drafty in winter, while those in the Middle East and Pacific complained of stuffiness and humidity. They were universally preferable to tents or improvised shelters. The huts provided a sense of semi-permanence and normalcy, even in combat zones. Troops could personalize their interiors to some degree, and the structures offered genuine protection from the elements and reasonable security during air raids when properly bermed. The Quonset hut also became part of military culture in unexpected ways. On Lamb Home in Orkney, Italian prisoners of war transformed their Quonset huts into a beautifully decorated chapel, complete with painted frescoes and improvised architectural details. Military bases used them as theaters for entertainment and morale purposes. The ubiquity of the structure meant that a soldier could be transferred from North Africa to the Pacific and still find familiar Quonset huts surrounding him, creating a sense of continuity across vast distances and different combat conditions. For Axis commanders, the proliferation of Quonset huts represented a demoralizing reminder of the industrial and logistical superiority they faced. German officers in their war diaries noted the contrast between German positions, often cold, wet, and inadequately supplied, and captured American bases with their rows of Quonset huts providing shelter, warmth, medical care, and hot meals. Japanese soldiers, particularly in the later years of the Pacific Campaign, found themselves cut off from supply lines and reduced to near-starvation conditions while watching American bases expand with what seemed like limitless resources. The curved steel shells of Quonset huts, visible from aircraft and from ground positions, became visual markers of American presence and power. The morale impact extended beyond frontline troops. In late 1941, as America reeled from Pearl Harbor, the Navy could point to Quonset hut production as evidence of American industrial mobilization and readiness. By 1942, when the Seabees were established and deployed, stories of their rapid base construction, centered around Quonset huts, filled newspapers and newsreels at home, providing reassurance that American forces were being properly supported. The hut became an icon of American know-how and adaptability, featured in propaganda materials and military recruiting films. The enduring legacy of the Quonset hut extends far beyond its wartime service. When the war ended in 1945, the military found itself with tens of thousands of surplus huts and no immediate need for them. The Federal Public Housing Authority, confronting a desperate housing shortage as millions of veterans returned home, promoted Quonset huts as emergency housing solutions. The government estimated a need for an additional 3.5 million homes in 1946. Surplus Quonsets were sold to veterans at low prices, sometimes as little as $1.50 per square foot. In 1946, a Quonset 20 could be purchased for $1,048, while a 40 sold for $3,436 plus shipping. Universities and colleges became major users of surplus Quonset huts. Michigan State College set up 75 Quonset huts to house veterans studying under the GI Bill, and similar installations appeared on campuses across the country. Many of these educational Quonsets remained in service for decades, and some still stand today as testament to their durability. New York City erected them in Brooklyn's Canarsie Beach Park and planned Quonset suburbs nearby. Entrepreneurs, including many former Seabees who had learned to appreciate the structures during their service, became Quonset hut dealers and distributors. Despite their utility and low cost, Quonset huts never became popular as permanent single-family homes. Veterans who had lived in them during the war often had no desire to continue that experience in civilian life, and the standard 20-footer's 960 square feet of floor space, much of it unusable because of the sloping walls, was inadequate for families. The 40-footer, at 4,000 square feet, looked and felt like a small airplane hangar, far too large for residential use. Stran-Steel advertised residential Quonsets with entryways and dormers attached, but these modifications couldn't overcome the fundamental limitations of the design for family housing. The huts found more success in commercial, agricultural, and industrial applications. Stran-Steel issued a press release in late 1946 listing 257 different adaptations of Quonset huts. Farmers discovered that two-story 40-footers made excellent hay barns, while smaller models converted easily into milking sheds. Quonset hut department stores appeared in small towns across America. Movie theaters, churches, repair shops, and small businesses adopted the structures, often hiding their distinctive curved profile behind false fronts to blend with more conventional architecture. Some architects saw potential in the Quonset form. In Nashville, Tennessee, the Bradley brothers purchased a Quonset hut that became the legendary Columbia Records Studio B, a cornerstone of Music Row. In 1947, French architect Pierre Charot built a Quonset studio on Long Island for artist Robert Motherwell. Architect Bruce Goff, who had served in a Navy construction battalion, built a modernistic chapel from 3 Quonset huts at Camp Parks, California, in 1945. The Daniel House in Knoxville, Tennessee, designed by James W. Fitzgibbon, Siamese 2 Quonset huts on a hillside to create a distinctive residence. The Quonset hut's influence on post-war architecture and construction was profound. It demonstrated that prefabricated buildings could be both functional and durable, helping to legitimize modular construction methods that would become increasingly important in civilian applications. The design principles, standardized components, simple assembly, minimal tooling requirements, and adaptability to various uses influenced thinking about emergency housing, disaster relief shelters, and rapid construction for growing communities. Modern arch-style metal buildings used in agriculture and industry owe a direct debt to the innovations developed for the Quonset hut. The hut also changed how military forces thought about logistics and deployment. The success of the Quonset system proved that with proper planning and industrial capacity, rapid global deployment was not only possible but sustainable. This lesson shaped post-war military doctrine and influenced everything from Cold War base construction to modern forward operating bases. The container shipping revolution of the 1960s, which transformed global commerce, drew on similar principles of standardization and modular design that the Quonset hut had pioneered. Today, more than 80 years after Peter Dejongh and Otto Brandenberger received their impossible assignment, Quonset huts remain visible across America and around the world. Some serve their original military functions at museums and historic sites. Others have been converted into homes, workshops, storage facilities, and commercial spaces. Charlie Parker's Diner in Springfield, Illinois, operates in a restored Quonset hut, serving as a reminder that these structures, designed for temporary wartime use, proved far more enduring than anyone expected. The National Park Service has designated Camp Endicott at Davisville as a historic district, recognizing the significance of the remaining Quonset huts as architectural and historical artifacts. The story of how Britain's Nissen hut became America's 150,000 Quonset copies represents more than an engineering achievement. It exemplifies a particular American approach to problem solving, taking an existing concept, analyzing its limitations, and creating an improved version through innovation and mass production. Major Peter Norman Nissen created a functional military shelter in 1916 that served the British Empire well through 2 world wars. Peter Dejongh and Otto Brandenberger took that concept and transformed it into something more comfortable, more versatile, and more suited to truly global warfare. They accomplished in 2 months what might have taken years under normal circumstances, and in doing so, they created one of the most recognizable structures of the 20th century. The curved steel silhouette of the Quonset hut became synonymous with military service for an entire generation of Americans. It housed the men who fought in every theater of World War II, sheltered the wounded in field hospitals from Normandy to Okinawa, and provided the logistical infrastructure that allowed American forces to project power across the globe. More than 1.5 million men lived and worked in these structures during the war, and millions more encountered them in the decades that followed. The Quonset hut changed the nature of warfare by proving that rapid deployment and adequate shelter were not mutually exclusive goals. It demonstrated that with ingenuity, industrial capacity, and determination, seemingly impossible deadlines could be met and seemingly intractable problems could be solved. In the end, the legacy of the Quonset hut is not found in any single technical innovation, though it had many. It is found instead in the philosophy it represented that American industrial power, properly directed and creatively applied, could solve problems that others deemed insurmountable. From a meeting in March 1941 to global deployment within months, From British skepticism to worldwide adoption, from wartime necessity to peacetime application spanning 8 decades, the journey of the Quonset hut mirrors the transformation of America itself during the 20th century. It stands as a testament to the men who designed it, the workers who built it, the Seabees who erected it under fire, and the millions of servicemen who lived under its curved steel roof. Simple, functional, and enduring, the Quonset hut earned its place in history not through elegance or sophistication, but through doing exactly what it was designed to do, day after day, in every climate and every theater, for an entire generation at war.